Hello everyone and welcome to SS2. It's my pleasure to take you through this chemistry course. Now, to continue our study of carbon and its compound, we are going to begin with or continue with the oxides of carbon. Remember that there are two oxides of carbon. The first one is carbon 2 oxide, which is a composite of air, which is one of the constituents of air. Carbon 4 oxide is in air in a percentage of 0.04%. While the other oxide of carbon, which is a lesser oxide of carbon, is called carbon 2 oxide, which is just a gas at room temperature. Now, if we are making comparison between these two oxides, we find that the carbon in carbon 4 oxide has an oxidative state of +4, while the carbon in carbon 2 oxide has an oxidative state of +2, like you have it here. Another good comparison you should remember is that carbon 4 oxide is what you call an acid anhydride. What is an acid anhydride? I'm sure you remember that an acid anhydride is an oxide of a nonmetal, in this case carbon, that when dissolved in water will produce an acid. This acid anhydride, which is carbon 4 oxide, has acidic properties as well. That means it can behave as an acid. While the other oxide of carbon, carbon 2 oxide, is what you call a neutral oxide. A neutral oxide is an oxide of a substance, in this case a nonmetal, that does not have any acidic or basic properties at all. Now, in this term, we are going to be beginning with carbon 2 oxide, and we'll find out some of the properties of carbon 2 oxide. Now, carbon 2 oxide, which is the lesser oxide of carbon, is very poisonous and it is a deadly gas. Now, we are going to see why in this short video.
When you're burning anything like gasoline or kerosene, wood, coal, or propane for heat, carbon monoxide poisoning can pose a serious risk. Part of what makes it so risky is that CO, that's the chemical formula, is odorless and colorless. CO can give you some very severe side effects at very small concentrations. Being exposed to about 400 parts per million, that's about 0.04% of the air around you, can give you a headache and nausea. That sounds bad, but it's not too bad. Bump that up to 800 parts per million, and in 45 minutes you've got the headache, the nausea, and you're dizzy. 15 minutes later, you could be unconscious. Now, what makes CO so dangerous? It's a molecular monkey wrench in our breathing process. Now, every cell in our body needs oxygen. This requires that O2 be transported through the body. Cells take it up, and then the cells have to use it. CO messes with all of these processes. First, let's talk O2 transport. The protein hemoglobin is tasked with binding O2 and shuttling it around. Now, O2 is a good passenger. It holds on tight, but lets go when the time is right. The same can't be said for carbon monoxide. It holds on much tighter than O2, about 200 times tighter. CO is also a bad guest, overstaying its welcome. CO's extra sticky nature means that O2 can't bind to hemoglobin and oxygen can't get to where it's needed. Want to stay safe from carbon monoxide poisoning? The CDC recommends the following. Have your heating system, water heater, and other gas, oil, or coal-burning appliances serviced by a qualified technician every year. Install a battery-operated or battery backup CO detector in your home and replace the battery twice a year. Don't use a generator, charcoal grill, camp stove, or other gasoline or charcoal burning device inside your home, your basement, your garage, or even a window near any of these. Don't burn anything in the stove or fireplace that isn't vented. Follow these tips and we can stay safe from CO poisoning and warm this.
Learners, in our lesson today we're going to look at carbon and its compounds. Our subtopic is carbon 2 oxide. We begin by looking at laboratory preparation of carbon 2 oxide. Now, carbon dioxide can be prepared by two ways: dehydration of methanoic acid or oxalic acid, 2. reduction of carbon 4 oxide using coke, that is carbon. So the first method, which is dehydration of ethanoic or methanoic acid, the reagents used here is concentrated sulfuric acid, which act as a dehydrating agent. So first we begin by looking at what is dehydration first. Dehydration is a process of removing elements of water or water molecules from a compound. Dehydrating agent is a substance which is capable of removing elements of water or water molecules from a compound. So A, dehydration of methanoic acid. The question is methanoic acid, RO, concentrated sulfuric acid, carbon 2 oxide plus water. Chemical equation is HCOOH solid, RO, concentrated sulfuric acid, CO gas plus H2O liquid. Now B is dehydration of ethane dioic acid, which is also called oxalic acid. Now the equation there is ethane dioic acid, RO, concentrated sulfuric acid, gives you carbon 4 oxide plus carbon 2 oxide plus water. Chemical equation is H2C2O4, RO, concentrated sulfuric acid, CO2 gas plus CO gas plus H2O liquid. Now collection of carbon 2 oxides. Now when you are using methanoic acid, the gas is collected after preparation. The gas is collected by over water method. Reason, carbon 2 oxide is lightly soluble in water. Now when you are doing dehydration of ethane dioic acid, because you are forming carbon 4 oxides, carbon 2 oxide and water, the mixture of gases is passed through concentrated sodium hydroxide or concentrated potassium hydroxide to absorb carbon 4 oxide, and then the gas is collected by over water method. Now if this gas is required dry, carbon 2 oxide is passed through concentrated sulfuric acid or anhydrous calcium chloride, then collected using a syringe. Below shows preparation of carbon 2 oxide by dehydration of methanoic acid. So the first diagram, this diagram here is by dehydration of methanoic acid. Where you place here methanoic acid here, you place here concentrated sulfuric acid. Now once the gas is prepared here, you are told that do not collect the initial sample of gas because it is impure, that is, it is mixed with air originally in the flask. After the gas is prepared here, it is collected by over water method here. So this is water, this is a trough, and this is the gas here, carbon 2 oxide. Now when you prepare the gas by dehydration of ethane dioic acid or oxalic acid, the setup diagram is as follows. Now I said with this a dropping funnel here. When you're using a dropping funnel, it should not be dipped in the solution. Unlike when you are using a distal funnel, the funnel should be dipped in the solution here. So this one you place here ethane dioic acid, you place here concentrated sulfuric acid, which runs inside here. It forms two gases, carbon 4 oxide and carbon 2 oxide. The gases are passed through sodium hydroxide concentrated to remove carbon 4 oxide. Then the remaining carbon 2 oxide is collected by over water method here. So this carbon 2 oxide, this one is water here. Now the other method, number 2, is reduction of carbon 4 oxide using carbon. The word equation is carbon 4 oxides plus carbon RO carbon 2 oxides. Chemical equation is CO2 gas plus carbon solid gives you CO gas. To balance the equation, place 2 where there is carbon 2 oxide. Now, after preparation of the gas is passed through concentrated sodium hydroxide or potassium hydroxide to remove unreacted carbon dioxide. Then the gas is collected by over water methods, because we have said the carbon dioxide is lightly soluble in water. Now, other sources of carbon dioxide can be combustion of charcoal and fossil fuels, e.g. kerosene, diesel, petrol, coal in insufficient supply of air. The diagram below shows preparation of carbon dioxide by reduction of carbon dioxide using carbon. The air enters through this section here. Air enters through this part here. So the reactions in this will occur in three sections. You have region A, region B, region C. Now in region A, there is plenty supply of air entering the chicle, allowing complete combustion of carbon to form carbon. The equation is carbon plus oxygen arrow carbon dioxide. Chemical equation is C solid plus oxygen gas gives you CO2 gas. Region B, carbon dioxide produced from region A rises up the region B, where it is reduced by hot carbon to form carbon dioxide. Now equation is carbon dioxide plus carbon arrow carbon dioxide. Now chemical equation is CO2 gas plus carbon solid arrow carbon dioxide gas. Balance equation, place 2 where there is carbon dioxide. Now in region C, in case there is plenty supply of air in this region, carbon dioxide from region B burns to form carbon dioxide gas. Equation is carbon dioxide plus oxygen arrow carbon dioxide. Chemical equation, carbon dioxide CO gas plus oxygen O2 arrow CO2 gas. Balance the equation, place 2 where there is carbon dioxide and 2 where there is carbon dioxide. Now in case of insufficient supply of air, some carbon dioxide produced in region B is released into the atmosphere. Now physical properties of carbon dioxide include: it is a colorless gas, it is an odorless gas, it is slightly less denser than air, as the density of carbon dioxide is 1.25 grams per centimeter cubed, while that of air is 1.2929 grams per centimeter cubed. 4. It is slightly soluble in water. Now chemical properties include: 1. Reaction with oxygen. Carbon dioxide burns in air with a blue flame to form carbon dioxide. Equation is carbon dioxide plus oxygen arrow carbon dioxide. Chemical equation: CO gas plus oxygen gas arrow CO2 gas. Balance the equation, place 2 where there is carbon dioxide and 2 where there is carbon dioxide. Now 2 is the reducing property of carbon dioxide. Now carbon dioxide is able to remove oxygen. Carbon dioxide is able to remove combined oxygen in metals, e.g. copper, zinc, lead and iron. So A, reaction between carbon dioxide and copper dioxide. Chemical equation is CO gas plus CuO, that's copper dioxide, arrow Cu copper plus CO2 gas. Now observation made when carbon dioxide passed over heated copper dioxide. During the experiment, you say black copper dioxide changes to brown. At the end of the experiment, we say black copper dioxide changed to brown, or you can say a brown solid is formed. Reason is carbon dioxide reduces heated copper dioxide to brown copper while itself oxidized to carbon 4 oxide. B. Reaction with heated lead 2 oxide. Chemical equation is CO carbon 2 oxide plus lead 2 oxide solid arrow lead solid plus CO2 gas. Now, observation made when carbon 2 oxide is passed over heated lead 2 oxide during the experiment, we say yellow lead 2 oxide changes to gray. At the end of the experiment is yellow lead 2 oxide change to gray, or a gray solid is formed. Reason: carbon 2 oxide reduces heated lead 2 oxide to gray metal. Carbon 2 oxide reduces heated lead 2 oxide to gray lead metal, while itself oxidized to carbon 4 oxide. C. Reaction with heated zinc oxide. Chemical equation is CO carbon 2 oxide plus zinc oxide arrow zinc solid plus CO2 gas. Now, observation made when carbon 2 oxide is passed over heated zinc oxide is during the experiment white zinc oxide changes to yellow and then finally to gray. After the experiments, a gray solid is formed, or you can say white zinc oxide change to gray. Reason is carbon 2 oxide reduces heated zinc oxide to gray zinc metal, while itself oxidized to carbon 4 oxide. D. Reaction with heated iron 3 oxide. Chemical equation is iron 3 oxide plus CO gas carbon 2 oxide arrow iron metal plus CO2 gas. To balance the equation, place 3 where there is carbon 2 oxide and then place 2 where there is iron. Observation made when carbon 2 oxide is passed over heated iron 3 oxide is during the experiment brown iron 3 oxide changes to gray. After the experiment, a gray solid is formed. Reason is carbon 2 oxide reduces brown iron 3 oxide to gray iron metal, while itself oxidized to carbon 4 oxide. Now, uses of carbon 2 oxide include it is used as a reducing agent in the extraction of metals. And then 2, it is used as a source of fuel when mixed with hydrogen gas.
Now let's briefly discuss some other properties of carbon 2 oxide not discussed in the video you just watched. When carbon 2 oxide reacts with metals and non-metals under the right conditions of heat and temperature, it forms a group of compounds called carbonyls. What are carbonyls? Now, carbonyls are a group of organic compounds that contain carbon bonded to oxygen and bonded to 2 other elements. These elements could be metals or non-metals. Now, we've heard that carbon 2 oxide forms carbonyl compound when reacted with some metals and non-metals. With chlorine in the presence of sunlight, carbon 2 oxide reacts to form carbonyl chloride. Carbonyl chlorides are also called phosgenes. The chemical equation for that reaction would be carbon 2 oxide combining with chlorine gas to produce carbonyl chloride. It can also react with sulfur vapor, a non-metal, to form carbonyl sulfide. And the chemical equation for that reaction is CO plus sulfur, which will be a gas in this case, to produce carbonyl sulfide. Thirdly, with metals like iron, nickel, lead, it forms iron carbonyl and nickel carbonyl respectively, as you have in the equations below. Now, another property of carbon 4 oxide you need to know about is its reaction, another property of carbon 2 oxide is its reaction with sodium hydroxide, that's NaOH, which is your caustic soda. When it reacts with sodium hydroxide, it forms what we call sodium ethanoate. Sodium ethanoate is still an organic compound that is from the weak. It forms sodium ethanoate, an organic compound which is formed from the radical CH3COOH of the ethanoic acid. Another property of carbon 2 oxide is its reaction with the red blood pigment called hemoglobin. When carbon 2 oxide reacts with hemoglobin in the blood, it binds itself to the red blood pigment to form carboxyhemoglobin. I'm not going to talk much about this because we've watched this in the previous video when we started. Now, before we close this lesson, let's quickly discuss how gases are collected in the lab in the method of gas delivery. Now, the collection of gases in the lab is dependent on the density of the gas. That means how heavy or how light the gas is. Now, there are two methods of collection, and the methods are upward delivery and downward delivery. In upward delivery, this is used to collect gases that are lighter, that is less dense than air. That means these gases are lighter than air. And during this method, because the gases are lighter, they tend to stay at the top of the gas jar. For instance, we have this diagram of a gas that is being prepared from a reaction. Now the gas is produced and it is collected into a gas jar. Now remember that this gas jar is not a vacuum, it contains air as it were. But when we are comparing the density of the gas and the density of the air in this place, we find out that the gas is lighter than the air. You bet me that the lighter gas is going to stay on top while the air is going to stay at the bottom. Now what will happen is that as more gases gets produced, the lighter gas, collected gas, which is lighter than air, will continue to fill the top of the gas jar while the air is let down. This type of collection of delivery of gas is also called downward displacement of air. It is called downward displacement because the lighter gas begins to displace the air that was in the container before it was introduced into the gas jar. Now, examples of such gases that are collected by this method are the gas we just treated or learned about, which is carbon 2 oxide. Other examples include ammonia, helium, water, hydrogen gas, and nitrogen gas as well. All of these gases are lighter than air and will be collected by upward delivery or downward displacement of air. The other method we talked about is the method known as downward delivery. In this method, gases that are heavier than air, that means they are more dense, they are denser than air, are collected via this method. This method is also called upward displacement of air, and we'll see why that is so in this diagram below. So you have this. Now, this is a chemical reaction that produces a gas, and this gas is delivered into a container by a method known as downward delivery. Now, seeing that the gas is air, it is logical to find out that they will settle in the bottom of the container. Now remember that this container, the gas jar, contains air already. Now as you introduce gas into the gas jar, because it is heavier than the air, it is going to settle at the bottom, while the gas, which in this case is lighter, will be on top. Now as you continually produce more gases and introduce them into this gas jar, the collected gas, which is lighter than air, will displace the air upwards. That means displace it upwards and the air is allowed to go out. Hence, this method is also called upward displacement of air. examples of the gases that are collected by like the oxide and chlorine gas. So these are the two methods of collecting gas in the lab. This brings us to the end of the lesson. I will see you in our next class.